Good morning, this is Kavipriya, Assistant Professor, EC Department, Synchronous College of Technology. Today I am going to deliver a topic called Synchronous Motor. So electric motors are basically classified into AC and DC motors. So AC motor which in turn classified into induction motor and synchronous motor. So synchronous motor is a type of motor that is used in industry for its constant speed. A synchronous motor is a AC motor whose rotor rotates at same speed as a rotating magnetic field. The stator's magnetic field revolves at a speed that depends on the supply frequency. Hence it is known as a synchronous speed. Hence a name called as a synchronous motor. A synchronous motor is the same machine as it has the same machine as that of the alternator or synchronous generator. A synchronous motor can be operated as a synchronous generator without changing the rating and design. When a machine converts input electrical power into output mechanical power, it is known as a synchronous motor. When same machine converts input mechanical power to output electric power, it is known as a synchronous generator. The other name for synchronous generator is a alternator. And this is a construction for a synchronous motor. The construction for synchronous motor is very similar to the alternator or synchronous generator. It differs from the induction motor based on the rotor design. And this is a stator part. It consists of yokes, stator coils, slots, and it consists of armature windings. And stator is a stationary part of the motor. Just like an induction motor, the stator core is made up of thin laminated sheets of steel or cast iron of good magnetic quality to reduce the hysteresis and the eddy current losses. The core has axial slots for holding the three-phase alternating stator field winding called armature winding. The stator's armature winding is supplied with the three-phase power through its input terminal. It is responsible for generating the rotating magnetic field RMF. Rotor is a rotating part of a synchronous motor. It has cylindrical shape and it holds a field winding. It is responsible for generating the magnetic field or poles. It is energized using a slip rings and brush assembly using a DC source. Usually small DC generator connected to its shaft is used for exciting the rotor. The rotor of synchronous motor can be designed in any one of the ways. First one, it is a salient pole rotor. Salient means pointing outward. Salient pole rotor has a protruding or projecting poles towards the armature winding. The rotor core is made up of laminated steel sheet for reducing hysteresis and eddy current losses. The field winding are wounded around each pole. The salient pole rotor has large number of poles. It is not suitable for high speed operations. It is used in low and medium speed. Physically, it has large diameter and small axial length. And second one is a non-salient pole or cylindrical rotor. Such type of rotor has a cylindrical shaped rotor made up of laminated steel. The core has a slots for field winding that are secured with the head of the wedges, while the unslotted portion of the core becomes a magnetic poles. It has less number of poles having smaller diameter and longer axial length. It is costlier than the salient pole rotor. However, the rotor design helps in uniform distribution of flux, mechanical strength and robustness. Therefore, such synchronous motor are used for high speed. And next is a permanent magnet rotor. Modern synchronous motor uses this permanent magnet rotor where the rotor has permanent magnets mounted on its surface. There are no field winding. The magnet generates the necessary field without the requirement of an excitation source. The permanent magnet is made up of neodymium boron iron since they are easily available and cost effective. Such rotor does not have a slip ring or brush assembly. The disadvantage of permanent rotor is that motor is not self-starting due to the rotor's inertia. And therefore, VFD, variable frequency drive, is essential for its operation. Next is a working principle of synchronous motor. Synchronous motor works on a principle of magnetic locking between the stator and the rotor magnetic field. Stator magnetic field is called as a rotating magnetic field. Opposite poles attract each other, therefore rotating magnetic poles attracts the opposite rotor poles, generating a rotating motion. A synchronous motor is doubly excited machine. It requires AC and DC supply for both the parts, stator as well as rotor, to achieve the synchronization. A three-phase AC is supplied to stator winding to generate RMF. The stator is designed to have the same number of poles as that of the rotor. The poles rotate at speed that is synchronized with the input frequency f. We call the speed as a synchronous speed. It is given by ns is equal to 120 f by p. DC supply is provided to the rotor winding to generate the fixed magnetic field. The DC source supply constant current. The rotor's magnetic field does not vary. The magnetic poles are generated at opposite ends of the rotor. The rotor's pole interact with the RMF of the stator and rotate at the same speed and as it attains a synchronous speed. If rotor rotates at the same speed as that of a stator RMF, there is no load torque. So rotor and stator poles align with each other. If mechanical load is applied, rotor starts oscillating about its new equilibrium position. This phenomenon we call it as a hunting. Rotor lags a few degrees behind the stator RMF and start developing the torque. As load is increased, the angle between them is increased until the rotor field lags by 90 degree behind the RMF. At this point, motor provides a maximum available torque called breakdown torque. If load exceeds this limit, motor stalls. Advantages and drawbacks of synchronous motor. Advantage is that it provides a constant operating speed. It has high efficiency and it is cost effective. Drawback is that it is not a self-starting one. It stalls if load exceeds beyond the breakdown limit. It requires an external DC source for its rotor field excitation. Its speed cannot be varied unless VFD is used. Synchronous motors are generally more complicated and costlier than the induction motor. And applications, it is used in constant speed applications, and it is used in a frequency, it is used as a frequency changer, and it is also used in a very low speed applications, and it is used in positioning. Due to this constant speed, they are used for precise positioning in robotics, just like servo motor. And general applications include grinders. It is used in pumps, it is used in compressor, fans, blowers, it is used in juicers, tap recorders, and is used in signaling devices, phonographer, and it is used in regulating and controlling devices. That's all about the synchronous motor construction, working principle, applications. Thank you.